Now we have multiple options in our workflow like plan, destroy. Now I will be going to run the apply and the workflow is getting started. And we can see the logs by using our Terraform Cloud console. And here we can see that the plan is reflecting here, and in 2 to 3 seconds we will be able to see the services going to create. So I will also check my AWS console. So once the services will be creating, so we can see our VPC and all other services. So let's go back to our Terraform Cloud console, and now we can see that the Terraform plan was successful, and now we are heading towards apply, and now it will start creating services over AWS. Now we can see that few of the services created like IAM and other services. Also it created the VPC, and now we can see VPC in our AWS console.
Hi everyone, I hope you are doing great. My name is Aman. Today I will be going to start one of the project series that we can say end-to-end DevOps project that you can add in your resume wherever you want to showcase your skills, and that will help you to gain hands-on on a industry projects. And this is one of the project that I have done few years back, and it helps me a lot when I was starting with DevOps, and with the help of those projects I have learned a lot. And also I will think that if you do the same project, so you will understand a lot of things like how to configure those things, and this will helps a lot. So this project will be into multiple parts. I will be going to separate the part with the dedicated tools. So if we are using a particular tool, so for that setup I will create a dedicated part. So with this way you will be able to focus on your stuff as well, and you will be able to give some time to work on this project as well. And one of the important thing is that while working this project you will face a lot of issues. So for that, if you need any help or you feel stuck, so you can reach out to me on my LinkedIn, and I would be really happy to help you over there. Or I would also suggest you to, instead of ping me on LinkedIn, you can also reach out to me on Discord server. So we have a Discord server that is Opstock, so you can feel free to join that and just put your doubts or issues, whatever you're facing. So I would be able to share my insights to help you fix the issue as soon as possible. And as we will be going to work on that project and that will be on cloud, so it will incur a lot of cost, and I can understand that thing as well. So let's start this series for this project, and I will just share my screen. So this is the architecture of this project that I have created. Not, I have not created this, actually ChatGPT created this for me because I was working on that and I don't want to spend some time on creating this architecture again, but I will create one good architecture. And this is just to give you demonstration how things working. But don't worry, when I've created this project 2 years back, so for that I have created one architecture, and this is the architecture that I've created. And with this help of architecture, I will be going to give you a high overview of this project, that what exactly we will be going to do in the next part and in this part as well. Also, I did some enhancements for this project because I don't want to keep outdated, as that a lot of things are changing in the industry and I want you to update yourself as well, and that is very important thing. So with this way we will be able to understand how things working. Our goal is not to deploy a particular application. Our goal is to implement DevOps practices, DevOps tools to deploy a particular applications. In future, we will be going to deploy 3-tier applications, 2-tier applications, or 10 plus or 20 plus microservices in the future projects. So let's first start with the architecture, and I will say the first thing again, I will go to the ChatGPT one, The thing is that we will be going to implement end-to-end Kubernetes project. And if I just give you an overview of what are the tools we will be going to use in this project. So one of the major tool is Jenkins. And with the help of Jenkins, we will be going to deploy our applications. So the first tool will be Jenkins, where we will be going to use it for CI/CD integrations. Then if I talk about CI/CD, so in that we will be going to use SonarQube for code quality analysis, as you can see here. Then we will have Trivi for file scanning. Then we will have dependency check that you can see here. OWASP, we will be going to use it. Then we will be going to use Trivi for file scanning, and along with that, we are also using Docker to build our images and push those images to Docker Hub. Then we will be going to deploy those images using the Kubernetes deployments on the Kubernetes cluster. Now the cluster would be unmanaged. Again, we can simply choose EKS cluster or any cloud cluster, but the point is here to understand how Kubernetes cluster set up. Because once you will be able to understand how Kubernetes cluster is set up using hard way or using KubeADM way, so it will help you while giving interviews, because they are not asking you that, okay, how did you configure EKS cluster? That is very simplest thing. Like the major thing is that how will you integrate things, like how will you join worker nodes to the master node. So that's the main important thing. Then after that, we have monitoring enabled, and for that we will be going to use Prometheus stack, and in that we will have Grafana and Prometheus. And for sending the metrics, we will be going to use node exporter. Now as you can see that all these things are somewhere using a machine, and for that I will be going to use AWS for that. And how much instances we need for this project? So there would be a 4 instances that we need. So as you can see here, so there would be 4 instances. The first one would be for Jenkins server, which will be going to big instance for us. Then we will have monitoring Kubernetes master and Kubernetes worker node. And if I talk about the cost of this project, so I have completed this project in 2 days. I can say, like when I've started for the first time 2 years back, I completed this project within 2 days, and it cost me around $8 to $10. But I would say if you complete it within 1 day, you will be able to complete this project. It will cost you around $4 to $5, maybe less than that as well. Now, one thing I've enhanced in this project. So if you just see this blog and if you read the blog, you can see that I have created the step-by-step guide to create the servers. And as I have implemented a lot of tools here, I don't want to do that manually. And for that, what I did, I just implemented Terraform that will help you to deploy your machines within no time. So if you're working on this project and you are stuck somewhere, feel free to just delete this entire setup. And what you can do, you have written some commands and all those things. So you can spin up the EC2 instance again and you can start working on that. I know it will take some time again because you have to configure new things again and again, but it is one of the recommended approach if you are scared from the AWS cost. So this will help you a lot. But the main intention is to implement Terraform because infrastructure as a code is must in today's industry. And I don't want to create multiple instances using manual way. Now, the next thing that is we will be going to see in this video, because this video we will be going to cover for infrastructure as a code, and along with that we will be going to set up a lot of things. So this is the high overview of this project. I hope it clears, and in the end we will be going to set an alert using Jenkins and Slack. So once our pipeline successful or failed or aborted, so you will get an alert on your Slack channel. So earlier it was email, and again, a lot of people in today's time don't want to see emails and they don't want to use email for that. So Slack is one of the amazing platform to get all those alerts, and it will have a good integration as well. So we will be going to use that. That's it about this architecture. I hope it clears what exactly we will be going to use. So if I just say that ultimately our goal is to deploy a Netflix clone application where we will be going to see few videos that is on Netflix. That is not a real Netflix, it's a clone Netflix. You will see theme of that Netflix provided by TMDB, which is like a IMDb, like movie database. And with the help of that, we will be able to see some videos. And if I say we are going to also implement security tools that I've talked earlier in this video, that OWASP, Trivy, and all those things, because it is very mandatory to do that. I am not going to say it's a full DevSecOps project, because a lot of things we used to implement in DevSecOps, and this is very basic things. And for this project, for this part, we will be going to focus on the infrastructure as a code, where we will be going to create our 4 machines, and then after that we will be going to use Terraform Cloud, and then we will be going to try to automate it. So it will save a lot of time for you as well. So this is the directory structure of this project, and we have application code, then we have Jenkins pipeline code, which is in Groovy script. Then we have Kubernetes deployment and services, that is one of the very small thing. Then we have Terraform, where we have set up EC2 instances and other networking services along with few IAM roles and policies. And then we have .github, and that will be going to help us a lot. So first of all, I will be going to start from Terraform, because our aim is to automate the machines. So let's start with that thing first. So the first thing that we are creating each and everything from Terraform, like from scratch, where I have configured networking services and created IAM roles and policies. And then in the end, I have configured EC2 instances. So the script is written here, and I'm not going to return it again because it takes some times. So I've just created it for you. It will save a lot of time for us as well. But I will be going to explain each and everything why we have written here, and that will be able to understand what exactly happening here. Okay. So this is the networking thing, and what I'll do, I'll just open this TFVers file. So along with that, we will be able to understand that, okay, what are the variables that we are using for this particular key, right? So this is the VPC section where the file name is vpc.tf, and one of the first service that we have created is VPC, and you can see the CIDR block. So I'm using the CIDR block is 10.0.0.0/16. So according to that, we can get the IPs, and around 65,000 IPs we will get from this. USG's one is one of the preferable region when you're working on your demo projects. Then environment is dev. I've just kept it whatever we can write. Then the public subnet count, that is 4, and it is not a private subnet, but we are using public subnets because it's a demo project. Our aim is to integrate things and deploy it. Okay. So the public subnets will be 4. Then we will have public subnet CIDR blocks. So here you can see the CIDR blocks. Then the availability zones for those public subnets. Then we will have instance count 4, and after that we are setting the instance type. So as I've told you that Jenkins need more CPUs and memory, so that's why we have to increase the instance size for Jenkins. So this would be X large, and I think it will have 16 GB RAM. And then after that, rest of the instance will have T3A medium, and it is fine for that. Then the volume size is 50, and the volume type is GP3. So I was on VPC. So as you can see that we are we have CIDR blocks that is coming from here, and the default thing like instance tenancy and DNS host names supports that I have added. After that, we have tagged, so things are coming from here, which is written in the local. Then after that, I have internet gateway. So to provide the internet connectivity to our instances, I've created that internet gateway, and that is attached to VPC ID, and that we have added the meta arguments, which is depends on. So it will run this after VPC only. By default, it's run always after internet gateway, but if you want to explicitly do these things, it will be good. Then we have public subnet. So as I need 4 public subnets for our 4 instances, we can create 4 times this block, but as we have one of the amazing feature is count. So with the help of count, I was able to create the public subnet 4 times without adding new code. And for that, I need to use different CIDR blocks. So for that, I've used elements. So you can see that thing here, and the same thing is coming from TFVARs as well. You can see the public subnet, public availability zone as well. So these are the things coming from here. And the public IP on launch, that means that our subnets will be public. So it will enable the public IP of the public subnet as well. That's which makes it public subnet, right? Then after that, we have route table. So this is very simple thing that you can make it public subnet, but again, this won't work for you. You have to create the route table, and you have to attach that route table with the internet gateway to provide the internet connectivity to your public subnet as well. So this is here I am creating the route table, and here we are providing the internet connection to that route table. And after that, we are associating the route table with the subnets. So you can see this is the count, and the route table associations will be going to work on all 4 subnets. And then we are attaching the route table association with subnet ID. In the end, we have security groups. Again, the point is that we are opening each and every port for now, and also egress is opening, so it can go to the internet, like our servers can go to the internet. There is no issue with that. While opening all ports, you should be specific with your IP range. So for now, I just kept it 0.0, but it should be specific IP range as I've written here. And also you can open multiple ports using dynamic block in Terraform, and I would recommend you to do that once you're implementing things in your real industry projects. So this is about VPC. Now let's go to the next thing, which is we have IAM.tf. So why I'm creating the IAM.tf? So the reason is that once the EC2 instances will be created, we need to SSH into those machines. And what is the very basic thing to do SSH is doing SSH from local. And I don't want to do that because I prefer session manager for that. When you want to SSH in your EC2 machines using session managers, then you need a particular role for your EC2 instance that needs a role to do that activity, and for that we are creating IAM role. So as you can see, this is the IAM role, and that we have assume role policy. After that, I'm attaching the policy, that is managed policy. So the policy name is SSM managed instance core. So whenever you want to use the feature of session manager to SSH into your machines, so you have to provide this policy. But after creating the role and attaching the policy, it won't work, because to attach the roles with the EC2 instance, it needs to be IAM instance profile. So for that, we are creating the IAM instance profile. So this is the IAM part that we have done. Then after that, we have gather.tf, and the gather.tf is generally I've used for gathering the latest version of OS. So we are using Ubuntu 24, and that's why it's trying to get the recent AMI ID so that we can use in our EC2 instance. Now let's move forward to the EC2 instance. So as you can see, this is only 25 or 26 line of codes, and this is, I would say that 15 to 16 lines will be going to create 4 machines. And along with that, we have the machine names are here. So the first machine would be Jenkins server, then the second one will be monitoring, then third and fourth related to Kubernetes. After that, if I just go to this EC2 instance block, you can see that the count of the instance is here, and which is coming from tfvats file is 4. Then we have subnet ID. So you can get that subnet ID is coming from the vpc.tf file. Then we have instance type. So instance type is coming from tfvars file. After that, we have instance profile that we have set up in im.tf. Apart from that, we have security groups. Then we have root block device. So for that, we are using 50 GB of the volume size, and the type of volume is GP3. And in the end, we have tags, and I don't want to keep it count.index like server 1, server 2, server 3. So I just kept the name of the servers relatable, and that should be meaningful. So for that, I used locals, and you can see here that we are using instance underscore names, and then we are using count.index. If it will create first machine, so it will take the name of that server as Jenkins server, and there would be some prefix. And after that, if it will be going to create the second machine, it will keep the name as monitoring server, and so on for the rest of the 2 machines. So this is the Terraform code to create all 4 machines. Now to create EC2 instances, we can just write Terraform init plan and apply command. But the main thing which is very important while working with Terraform is Terraform state management. And if you know that when you're working with state files, you need to understand that the state file should be secure, and you have to find a way that you can't lose that file, and more than 1 or 2 people can work with that infrastructure. So let's say you have 5 people in your DevOps team, and they want to do some changes in your Terraform, in your existing infrastructure. So they should have tf state file first, right? And for that, we will be going to use Terraform state management, and that is, we can say, backend. So if we just come here for the backend, so this is the provider, which is Terraform, and then we have AWS provider as well. And the version we are using for Terraform is 1.13.3, and along with that, we are using AWS version, which is 6.14.1. And then the next main thing is this block, which is cloud. So now, why cloud is there? So if you have worked with S3 state management, where you are using S3 to store TF state files, right? So if I just write backend, you can get that it is allowing me to write the scripts over here, and you can store your TF state files and TF state locking as well in your cloud storage. For that, we have S3. But this time, I'm not going to use S3, and we are integrating one more thing that will help you to understand one more tool, which is Terraform Cloud. So till now, you might have worked with Terraform only, where you are creating the scripts, you are writing the scripts and creating the machines over AWS or any other services that you are creating. But I know that a lot of people are not aware what is Terraform Cloud. And for that, you don't have to be worried for that. What I can say is that if you're new to this Terraform Cloud, I would recommend you to watch this video that I've created few days back. So this is the video. I will provide the link for this video, and like I can say, this is one of the masterclass for you to learn Terraform Cloud, and it is very easy. So like in 2 to 3 hours, you will be able to understand Terraform Cloud, and with this video, you will be able to get some interview question as well. So you will be able to answer those questions. So let's get back to the main thing, which is I was talking about the cloud block. So that blog thing is already mentioned in that video as well, but I'll explain you in the brief for this project. So this is the cloud block that I've added, and it means that our state file will be going to store on Terraform Cloud. So now let's go to the Terraform Cloud. So I have the Terraform Cloud here, and along with that Terraform Cloud also manage workspaces. So you don't have to create the workspace manually, and it will create Terraform state files for a dedicated workspace. So whenever you run a Terraform init plan and apply, it will have the state files. So if I just click here, this is the workspace that I've created earlier. And you can see that we have the state files here, as you can see in this test. If you just click on this state sections, you will be able to see all those state files, and currently the state file is in unlock state. So if you want to lock it, you can lock it as well. So this is user interface for Terraform Cloud, and it is amazing. You will be able to understand what are the services that is creating. So if you want to check the plan and apply, so you can just click come here. You can see the plan for destroy that I was doing when I've completed this project. So I was destroying resources, so it was showing that okay, the resource will be going to destroy, and then after apply finished, so you can see the resources are destroyed. So it is one of the amazing thing you should try, because you will understand what is Terraform Cloud, and it is not that much hard. It will just take, I think, 2 to 3 hours to understand. Okay, so that's the main thing. But how we will be going to work with Terraform Cloud? For now, you just have to write here cloud, and the things required for cloud, like how it will authenticate with the Terraform Cloud, how it will know that in which workspace I have to create the Terraform TF state files, like which workspace I have to use for TF state store. So all those things will be going to use, and will be going to provide it later on, and that I will also cover. So this is related to state management. Now, if I just go to the next thing, which is .github. So if you are seeing that why .github is there, so inside the .github folder, there is a workflow folder. And if you have worked on GitHub Actions, so whenever you want to create a new workflow, you used to create workflow inside workflows folder, and we have workflows. Now you might say that, Aman, you show me that Jenkins is a part of this CI/CD and GitHub Actions was not there. I totally understand. It was not a part of this project, but I just implemented it. So the reason is that why I've implemented this GitHub Actions along with Jenkins, that I'm too lazy while running the Terraform init plan and destroy command. So what I did, that I just wanted to get rid of those things. So for that, I just created this workflow or pipeline. And again, because if I will be going to do the same thing on Jenkins, for that I need to have a server, and I don't want to do that. So that's why the main reason is that to create this workflow, and it's not very difficult workflow. It's very simple. If you are not good in GitHub Actions, no worries. This is very basic things that we used to work on the GitHub Actions as well. So I'll just tell you in the brief what exactly we are doing in this workflow. So the first thing that we are doing is, this is the name of the workflow, which is infrastructure configuring using Terraform on AWS. Then this is the on section. So on section is generally used to tell that when that workflow should trigger. So you have heard about, like, we used to trigger on any kind of push on the repository. So currently this is a workflow dispatch. It means that I will be going to run this workflow manually. So there is no push or there is no pull request kind of trigger. Then after that, environment variables that we have set. So I was talking about the Terraform Cloud, right? This line. So this line needs three things, and those three lines or three things will be going to come from here. So the first thing will be API tokens. With the help of this, it will authenticate with the Terraform Cloud. Then it will have Terraform workspace. So this will come from secrets of the GitHub repository. And then we will have cloud organization for Terraform. And this will be the Terraform Cloud organization that will also come again from GitHub Actions secrets. And after that, this is the permissions, which is read. So I'm providing the read permission to my GitHub runner. Then after that, we have jobs, which is the main thing. And the jobs will be going to run on Ubuntu machine, which is Ubuntu 24.0.4. Then we have environment. So this is default environment that I'm using. Then the default things that I'm setting, which is working directory is Terraform and the shell is bash. So I will be able to run Linux commands here. And to run the Terraform commands, I need to be in the Terraform directory because all the Terraform code is present in the Terraform folder. Then after that, the main thing is the job thing. We have steps. So the first step of this workflow is checking out, which means that it will clone the repository first in the GitHub runner. Then after that, it will setting up the Terraform. So for that, like to run the Terraform commands, like it should have installed the Terraform. After that, it will, while setting up the Terraform, you need to have CLI config credentials token. So it will be able to authenticate with Terraform Cloud. And then we will have caching enabled. So, Terraform init commands takes a lot of time while installing the providers and all those things. I think it's more than 1 GB. And that's why I've enabled the caching. So once it will run the workflow first time, so it won't take much time in the later workflows. Then after that, we have initializing the Terraform command. So this is to initialize the Terraform. Then next we have format check. So if there is some issues with the format that we use to run Terraform fmt command, so if there will be any issues, so it will fail the pipeline. After that, we have Terraform validate. So it will check for the syntax. And in the end, we have Terraform plan, apply, and destroy. So if you see this section where we are providing the inputs, so in this inputs, because as I was saying that I am too lazy, so I don't even have to write the command name as well. So I'll just need to click from the drop down whatever I want to do. If I want to plan the Terraform code, so I'll just need to select the plan. If I want to do apply, I can do that as well. And same for the destroy as well. So the same thing is working here. You can see here that it is taking the input, and if the input is plan, so it will run the Terraform command. And if the input is apply, it will run that command, and same for the destroy as well. So this is the basic GitHub Actions workflow. So now we will be going to work with Terraform Cloud first because we have to authenticate and configure Terraform Cloud. So because I've already created Terraform workspace and all those things, so I will delete this workspace first. So you will be able to understand that how to create things from scratch. So what I'll do, I'll just go to the view settings, and you can come here for the destruction and deletions, and just you can see that delete workspace. So I'll click on it. You have to provide the delete prompt, and it will delete my workspace. So now as you can see that we don't have workspace, so I'll simply click on new and click on workspace. You can also create a new project, and under that project you can create dedicated workspace. So I will use default project, or I will use Netflix clone project for now because I've already created this. And after creating this, I can simply click on CLI driven workflow because we will be going to run the Terraform CLI commands as well. And then I will provide the workspace name is Netflix clone project. So this is the workspace name and this is the project name. And you can add the tags according to your requirements. So I'll just click on this create. Okay, so now you can see that we have the things are present, and it is saying that how to set up your CLI driven runs in your actual environment. So it is saying that ensure you are properly authenticated into HCP Terraform. And as you know that I was saying about the token, so we have to generate that token first, then we will be able to use this thing. Now the next thing is that you can see the Terraform Cloud. So if I just copy it first and let's go to the backend.tf, and you can see that the Terraform block is similar from the first line you can see, and the cloud section is already there. But the next thing is you can't see that the things that present here that is provided by Terraform Cloud. And we are not going to provide it here because we are using the TF environment variables that you can see in the terraform.yaml. So these are the predefined Terraform environment variables that recognized by Terraform itself. So wherever Terraform will see these things, it will use them at this place that I was showing you here. So if it's looking for organization, we have already set the predefined recognized Terraform value, which is CLI organization, right? That I've set it in the terraform.yaml file. And the same thing with workspace as well. So we don't have to do anything. We already did the same thing. What we will be going to do is we will be going to set those values in our GitHub actions, secret sections. So I'll just remove this from here. Then it is asking us to run the Terraform init command to initialize the workspace, and then we can run the Terraform plan or apply to start first run for this workspace, right? So this is the very basic thing. So the next thing is to generate the token. So for that, you just need to click on your profile, and then you will have account settings, click on it. After that, you will see tokens, and I have one token already. So what I'll do, I'll just delete this token, and we will create another token, which is by clicking on here, create an API token. I will write Netflix clone token. And you can also set the expiration. So for now, I'm just keeping it for 1 hour. And as this is the series I will be going to do in a multiple part, so I won't be able to complete this project within 1 hour or 2 hours. So that's why I'm just keeping it for 1 hour. So you can also change the expiration of this token. So what I'll do, I'll just keep this expiration time for 7 days, and then it will provide me the token. So you can see the token here. I'll just copy it here. And now it's time to go to our GitHub repository where I've made the changes. So here you can see that. So this is the repository of this project. Here you can see the Terraform code is here. Then we have .github as well. And if I show you the actions, so you can see that I've already run multiple workflows for this project. So as I've copied the token, I need to use the token, and I need to go to the settings options. And here you can see that we have security options, and in that security we have secrets and variables. And then you have to click on actions, and you will be able to see there would be 3 repository secrets. So the first is TF API token, then we have cloud organization, then we have workspace. So I have already created this. So if you haven't created this, you just need to click on new repository secret, and then you will be able to create a token. So I'll just click on this edit option, and I will provide the value that I got, and I'll just click on update secrets, and it will ask me to authenticate. So what I'll do, I'll just authenticate it first. So now you can see that the last updated time is now. Now the next thing that we have to update is TF cloud organization. So most of the time cloud organization would be same, so I won't change it. So the next thing is TF workspace. So I might have changed the name of the workspace as I've created the workspace again. So what I'll do, I'll just go to my Terraform Cloud, and here is my organization. You can see that the organization is already same, so I don't have to change it. You can add it. Okay, so this is the workspace name, so I'll just copy it from here, and then we'll go to GitHub, and you can see that I've pasted the workspace name. So we have provided all these things. So now we can run our workflow. So what I'll do, I'll just click on this, and I'll tell you that we will be going to face one error. And if you are able to guess what exactly the error, so I can say that you're already good in this Terraform Cloud. So for now, I'll just run the workflow and let's see what exactly the error we will be going to see. So I'll just, as you can see that I don't have to do a lot of things. I have just to select the branch, and then I have the options, the plan, apply, and destroy. So first we will be going to run the plan, and let's see, let's refresh this browser first, and the workflow is getting started. And let's see the output and logs, and you can see that plan is also started. I think yes. So I was expecting that error. I thought that I've already provided the credentials, but no. So as you can see that error is related to no valid credentials source found, and the credentials is related to AWS. If you see the provider, so you will be able to understand that it is looking for the AWS credentials, and that is legitimate point, because till now we have provided the credentials for Terraform Cloud that we will be going to authenticate for TF state management. But the main thing is that as we have to create our EC2 machines and all those AWS services on AWS cloud, so for that we need to provide the credentials, and in our GitHub repository we haven't set that those credentials. So for that we have to set those credentials. So the main thing is, where do we have to provide the credentials? So let's see, where do we have to provide the credentials, and what are the alternatives that we can use to provide the credentials of AWS. So let's come to the Terraform Cloud workspace first, and you can see here is the settings option. I will just tell you a few things in a very brief. So you just need to come to the execution mode, where it is telling you that when you are running the Terraform plan, where exactly the Terraform plan and all other operations going to run. So the first thing is project default. Now the project default means that currently it's set to remote. It means that we need to understand the meaning of remote. So the meaning of remote is that applies, like your plans and applies occur on HCP Terraform's infrastructure. So as you know that as it's saying that remote, so Terraform plan and apply will be going to run on HashiCorp cloud platforms infrastructures like machines, right? So it's saying that you and your team have the ability to review and collaborate on runs within the app. Then we have local. So it is saying that local means that we are running the Terraform plan and apply on our machines. So currently we will be going to work with remote. Now, how will we be going to provide the credentials for both of the way? So let's first start with local. So locals mean it will be going to run Terraform commands on my local machine or my GitHub runner. So for that, we can simply provide the access keys and secret access key in our GitHub actions, secret sections, right? That there where we have added our TF API token. You can use that way. That is very simple way. Then the again one of the convenient ways to add your access keys and secret access key here in this workspace, and it will use those credentials in HCP cloud infrastructure to create those services. So as you know, that is already currently set to remote. So what I'll do, I'll just keep it as it is, and I'll go back here, and you can see here variables, and here we have to provide the variables. So these are the workspace variables that we have to add. So what are the variables we have to add? So you know that again, AWS have the predefined and recognized variables that we have to provide. We have one of the GitHub Actions blog that is written by GitHub Actions itself. So I'll just do automate Terraform Cloud. Yeah, sorry, it is written by HCP itself. So this is automate Terraform with GitHub Actions. So this is the blog that you can follow. It is saying that the environment variables that we have to use. So this is the variable for the access key. So I'll just copy this one. So I'll just go to the workspace variables, and this is my key, and there are variable category. So the first is Terraform variable and the second is environment variable. So make sure you should select environment variable, and then this is the value, and after that we need to have access keys. So for that I will be going to generate a new access keys for that. And what I'll do, I'll just go to the IAM section of this, and I'll go to my user, and after that we will be going to generate our security credentials. And as you can see that I have already access keys located. I'll just delete this one. Now let's create the new one. So I'll click on command line interface. Make sure to check this and click on next. I'll provide the name Netflix clone, and here we will get the access key. So I'll copy this access key and paste it here. You can keep this access key as secret or not, it's up to you, but make sure to set true to sensitive to secret access key ID, because that is very important. So I'll just click on add variable. So the one variable is already added. Now we have to add the next variable, which is, I'll take it from this blog, and this is the key. And again, I have to select this as environment variable. Then I'll get the secret access key here, and I'll keep this sensitive. And I hope you are not able to see this. I'll click on add variable. So we have set the workspace variables. So now we can rerun the workflow. So I'll just click on this button, and it will ask me to rerun job. So I'll just click on it. And the workflow is getting started. And this time we should not be able to see any error, and it should run the plan. So let's see. So now you can see that it is able to read all those things, and Now the plan is successful that the resource 19 will be going to add. And if I check in my workspace, it's checking for configurations. So as it's waiting for the configurations, so once we will run the apply, we'll be able to see all those resources. So I'll just click on actions. This time we will run the apply. So I'll select the apply. So go to the logs, and also we can check it from here as well. So if I just refresh it here, so within seconds you will be able to see the resources that is going to create. And yes, we can see. So now it's running the plan, because as we triggered the apply, so that's why it is showing the plan now. So it is waiting for the resources, and also we can see this console as well. So we will be able to see the VPC's creation. So currently I have only one VPC. So once the VPC will be going to create it, it should have two VPC. So let's go back to the Terraform Cloud. Now it's running the plan. So you will be able to see the created services live. So now you can see that the instance profile and role is created. VPC is also created. So if I will go to the VPC console, we will be able to see two VPC. So yes, we have the VPC. Now we will be able to see the subnet as well. So yes, I'll just filter out with the particular VPC that we have created. So we have 4 subnets. Then we have one route table, and that should, the associations are here. Then we have internet gateways. And after that, let's see the EC2 instance. It should create the instance. As we can see that the apply is completed here, and also this is completed. So we should be able to see our machines as well. So yes, we can see the machines. Now let's suppose if I have to connect to that particular machine, so I'll just try to connect with Jenkins server. So I haven't provided any SSH key here. You have seen in the script. If you want, you can provide using key pair key value, but here what I'm doing, that using the session manager, I can just click on connect, and I will be able to SSH into that particular machine. And that is very easy, and this way, like, no one can get the access. So if you have the AWS account access, so only you will be able to access the particular machine. So what I'll do, I'll just log in as a Ubuntu user, because this is Ubuntu machine. And you can see that we have the machine up and ready. So yes, this is it for this part 1, and I hope you have learned something new. We will have a lot of things in the upcoming videos. We will be going to set up a lot of things. So in the next part of this project video, we will be going to set up Jenkins with the multiple integration like SonarQube, Slack integrations. Then we will install some few tools. Yes, so I'll see you in the next video. Have a good day.